Hey, what's up, guys? This is the bonus tutorial for the skin shading video. And so I figured I would cover some of these extra nodes, even though I personally don't use them. I think most people shouldn't, and that's just my opinion, just because I think they're kind of outdated and a little weird to use. And I usually just recommend everybody uses the redshift material, the RS material, just because you have way more options, way more control. And the specific redshift skin and redshift SSS, those two nodes, I mean, they work, but they're just, I don't know, they're just weird to me. Like, you can get the same thing and better with the RS material. The RS material just feels more intuitive to me, but that's just because I come from more of an Arnold RenderMan background, and they also have Uber shaders, which just does everything, and or like the AL Surface, the legendary AL Surface, great node, and so I'm used to working that way. I know that V-Ray and Octane and other engines, people are used to the one node does that job task. So, but Redshift is more like Arnold in terms of his shading system. So I recommend people just use the RS material, and so that's why I covered that in my skin shading. But since there's a lot of confusion with the other nodes, I'll kind of go over them. But again, warning, I don't recommend using them. I personally don't use them. So, but I'll kind of explain what they do and why I think you might as well just use the RS material. So, we've got this scene set up here. It's just the two cubes from earlier with some displacement, an RS noise, and a displacement just to break up the cube so you could see the SSS. And so, let's actually start from the top. So we're going to do the RS material multi-scatter SSS. So we plug this in, and let's actually start an IPR, and let me save this. So what you'll notice is if we go in here and we check out what's going on. Right now our properties, it's just the diffuse is a gray. So what I like about the RS material is that you still get all these other options. So you could adjust the IOR, the reflection, backlighting, do all kinds of crazy stuff still. But if you want your object to have a little more oomph to it, look a little better, like let's say you're making a plastic or something, plastics usually have a nice little bit of SSS. So this is an option. So the RS material lets you add a little extra to stuff while the other nodes don't give you all these options. That's why I recommend using them. So in this example, we're just using the multi-scatter. Now, multi-scatter, the ray trace multi-scatter, it's great. It's awesome. I love it. Only problem with it is that it's noisier and slower to render. Why? Because it's more complicated. So light is coming in, bouncing around several times, and then exiting. And so it takes longer to calculate all these bounces going through the medium. Now, I already explained pretty much all these parameters. If any of you have ever seen an AL Surface tutorial, this is basically what this is modeled after. The AL Surface subsurface scattering, which is the dipole method. And right now we do not have the random walk method. We will eventually, according to Panos. So, it'll arrive when it arrives. The dipole method is great, though. It works. And so what the dipole method is this. You basically have whatever your diffuse color is, your texture, whatever, right? Whatever you want, your diffuse. And then if you want to add extra subsurface light bleeding in, all you do is activate it and activate a layer. So right now we have it red. If we wanted it to be blue, you just change the color. It's very artist friendly. Basically, you don't have to think about it. You just change the color to whatever you want, and it does its job. It just works. And so It's simple. You have weight, so you can either turn it on, off, um, the overall SSS on or off, and then weight. This would be like if you turned it into black, and so like if the SSS effect was black. So I just leave the amount and weight at 1 when I'm working with SSS, just because I just want it on. I want it to work. The only time I would ever adjust weight is if your object needs variations of thickness. So if it's not consistently thick, so like I mentioned in the skin tutorial, if you painted a texture map where the nose or the cheeks or whatever were different levels of gray, white, and black, and then you plug it in here, that would vary the thickness radius. And so the weight would mean there is no SSS or there isn't, and then the radius you could adjust, you could paint also to tell it this area is thicker, this area is shallower. And so what weight does is it either turns it on or off. So like if your character had eyebrows in a texture, you would obviously want to paint out that area and then have no SSS because it's not skin. And then you would paint a radius map because radius adjusts how deep the SSS light is bleeding in. So if I increase this, you can see it's basically going through the whole object. And on this cube, it's going all the way through. And so you might be wondering, why did the cube turn blue, and why is there this weird blue fringe lighting, and why am I getting this bluish color? And so how SSS works in the real world is basically the light comes in and some light gets absorbed, attenuation basically, and then some of the other light bounces back. So your color here is basically what's coming out, and then what's left over basically is this bluish color. The opposite, if I were to look at the color wheel, this is the red. The opposite side is this color. So if I were to do this, see, now this cube is red instead of blue. And so that's how subsurface scattering works. Basically, some light comes in, bounces around, gets absorbed, and some of it bounces back out. And so that's you're going to get this when you have SSS levels this high. So I usually never crank it up that high. That's just super beyond what the object's even thickness is. So I'm usually down to 2, 1, where you could see the light is bleeding in a little bit, and then what happens is the light rays start to get absorbed, attenuation as it's called, and the absorbed color ray spectrum dies out. So what's happening is red is dying from absorption, and so the color that's left is the opposite of red, which is this blue, and that's why it's fading from red to this bluish color. That's just the way physics and light works. So that's what makes this so simple to use. Basically, all you do is just turn it on, pick the color you want, and adjust the radius, how much or how little you want, and that's about it. It just works. We also have these 2 other extra layers. So these are if you want to do more complicated stuff. I'm not going to say it's the older way to do it, but it kind of is. A lot of like the newest update of Arnold 5 and stuff like that, they're just getting rid of all this. They're just saying, you know what, this is just extra parameters. An artist can do everything he needs basically with 1 layer. Technically, people will say, you do need the top layer of skin, the medium layer of skin, and the third layer, the deep layer. So if I were to change this to like another red, the deep layer, and actually, turn it on. What's happening is this red is so deep in there that it's attenuating. And so it's not attenuating, basically. It's going in, but there's a third layer of this same red deep inside the object that it's not being absorbed and turning blue, basically. And so I personally I don't mess with it. It's just not. I don't. Like I said, I'm just like, keep it simple. Let's just use one layer, you know. But this does the same thing as this, except it's deeper in the object. That's the way to think of it. And but that's just not how I work myself. So, anyways, hopefully that explains what's going on here. And so, if you've ever watched an AL surface tutorial on subsurface scattering, this is the same thing. It works the same way. It's actually what it's modeled after. So let's close that. So yeah, this is, in my opinion, this is the way to go if you're going to be doing skin or anything complicated, that has complex shapes and stuff. Use multiple subsurface scattering and just keep it simple. I don't bother with these extra layers, and just use the colors that you need. And adjust the radius to your needs. So if I drop it down this low, it's just a little subtle SSS in there on the edges. And then obviously if I crank it up, then it's going way through the object, and we start getting a red in the middle, because the opposite of this blue is like this orangey reddish color. So anyways, let's move on. So the next one we're going to do is single scatter, which in my opinion is really easy to use if you just keep it simple and think of it the same way as the multi-scatter. And so if you just think of multi-scatter as just forget about these two sections and just deal with this, the single scatter is basically the same idea. Except the difference is that this is a lot faster to render because the light is only going in once, bouncing one time, and then exiting, and that's it. And actually, I did not. Oh, this doesn't have a phase. Okay, well, single scattering has a couple an extra option called phase, and so I'll cover this. And so, basically, this red color is 0.5. If I change, let's just make this white so it doesn't confuse anyone. And let's make this 0.5, the same color red. And so if I plug this in, and reload, you'll see, let's make the radius of 1, that let's actually put this down lower so the radius scale is smaller. So you'll see that this little red edge and the same red color, and the only thing we're changing is the radius, basically the thickness and the scale of the thickness. You get almost the same effect. As a matter of fact, let me do a bucket render. Make sure this is ray traced. Yeah. And so we can save a screenshot just so I can compare the two, show you guys the subtle differences. And as you can see, ray traced SSS is kind of noisy, but you know, it is what it is. And so this is multiple scattering here, and now if we compare to single scatter, for some reason I'm getting a bunch of fireflies. I'm not sure if it's due to the settings I got or the samples. Oh, the samples are low. That's why. So let's crank this up to 512 just for our example. As a matter of actually, I think I gotta override it. Out. Redshift settings. Sample overrides. Yeah, let's just do 1024. Just something a little heavy, just to make sure we get pretty clean samples going. And yeah, let that render for a second. Actually, I don't know why that's there. That's kind of weird. It's not the specular. Phase 0, scatter scale 1, 1. It's pretty weird. I am using the experimental build, so for all I know it's a bug, but let's see. Subsample intensity. Let's just clamp these values down and see what happens. Yeah. So it's just due to the subsampling is too high. But so if you guys ever run into weird little fireflies, sometimes it's caused by the subsample intensity. That the values are beyond 0 to 1. And so you start getting weird firefly issues. And the only way to clean it up is either do that or increase your samples. But okay, cool. Anyways, actually I could probably lower my override. Let's drop this down. Something like 256. That should be enough. And let's go back to the mat. So if we zoom in here, you'll notice, cool, we've got a similar edge glow. Except some differences. One, the multiple subsurface scattering, like I said, is way noisier. Why? Because it's just more complex. It's more real life, basically. SSS doesn't just go in and bounce and get out in one shot, you know. It does multiple bounces, and it's more complicated. But, and it looks better, in my opinion, for complicated stuff. And you get more of a nice blending of light going inside the object because it's bouncing multiple times. But, you know, sometimes you don't need that. I mean, this still looks pretty good, and you know, it's doing its job. And it's cleaner. So maybe this is enough SSS for you. You only need one time in, one time out, and that's it. So yeah, but it's a similar effect if you look at it. Except this SSS just looks nicer, in my opinion. It looks more like a solid, thick object, while this, I mean, it looks like SSS, but it looks like it's not bleeding through the object as much. And so, again, this is because this is single scatter. It's scattering one time and exiting. Now, but what's cool is it's really easy to use, just like the multiple scatter. All you got to do is just turn on the weight, activate it, or not on refraction. Turn on the weight on the absorption scale at 1, a scatter scale, and then you just increase the transmit. You change the color. I think this comes in black normally when you first make the node. Let me make sure, actually. RS material. Yeah. Oh no, it's white. And then the scatter's 0. This means it's off. So if we, let's turn back on IPR mode. And so if we take the scatter scale, put it at 0, what it does is it effectively turns it off. And that's basically like turning off right here in the amount, going to 0. It's the same thing. It just disables it. And so what you have to do to first start getting SSS, so you got to turn this on. So you could try 0.1, and you'll notice the scattering's it's a little bit. You could try 1, and it's more obvious. You could try 10, and that's probably too much now. I don't even know what it's doing. Let's try 5. And so you can see that it's coming in, but it's scattering, and that's it, And so all you got to do if you want a different color, just click on different colors, and it works. It just works. And so there's another option, extinction. I personally don't use it. It's a little weirder. I like transmittance because it's just this easy to use. You just choose the color that's going to transmit inside, and you increase the scale. Now, the other option, phase, what this does is basically you think of the lights coming in, how much of the light is penetrating away from the camera, and how much light is coming towards the camera to you, the viewer. So if you go the opposite way on phase, this is away from the camera. And so basically the light is bouncing and then going away. This is a biasing effect. And if you go the opposite side, the light's coming in and then bouncing at you. So it gives a cool effect, don't get me wrong. I mean, this is like a neat looking effect, like a glowing edge effect. But technically, it's not physically accurate subsurface scattering. 0 is more accurate, where it's half going away from you and half going at you. But yeah, this is what phase lets you do. It lets you control the direction of the light bouncing back to the camera. What else? The scatter coefficient. This you should just leave black and white. So if I drop this down, you'll notice that the light's coming in and moving. It's basically not. It's making it denser. The object's density is increasing, where it's not scattering light as much. So you can actually make a texture map and plug it in here, where black means the object is really solid, and white means the object is thinner there, and things can pass through. So you can think of this parameter as the equivalent to a similar parameter to like weight and radius, where down here the scatter scale increases or decreases the scale of the scattering throughout the object. This is a similar parameter, basically, how radius and the weight adjust how much is being scattered and the thickness of the object. So that's something to keep in mind. What else? If let's just do a 0.5. Now, in this example, I believe, yeah, 0.5, 0.5, 0.5. So what's going on here is what happened to our SSS. And so what's actually occurring is that our transmittance color and our scatter color, which is the color that's being scattered, and the color that's penetrating in, they're opposites. So 0.5, 0.5, 0.5. And you'll notice that that's what's, once I change the color to something else, it starts to work again. And basically, that's caused by that, what I was talking about earlier, where the colors cancel each other out, because This red, this 0.5, is the exact opposite of this color. So if I were to go up or down, it doesn't matter, the value. The value itself doesn't matter. What's mattering is the hue of this color, and the hue of this color just so happens to be the exact opposite of this bluish color. So if I actually shift the hue over, now it starts working. And so the way you could think of both of these in a balance is basically think of like a river, or not a river, like an ocean, where the transmittance and how you balance it with the absorption and the scattering, what you're getting is basically the depth, the further the light goes in. And actually, let's put this phase back at 0.5. Oh, no, not 0.5. 0. The further the light travels in, different colors get attenuated and kept. And so that's what's going on. I personally don't mix these two up. I just like to keep it simple. So I just stick to white, black and white, decrease it as needed, and adjust the scaling as needed, and change the color. And then adjust the absorption so that it absorbs more or less. So if I increase this, it's absorbing a lot of it. If I go this way, it's absorbing some of it. We're getting a little bit of SSS. So it's a little more subtle. And then you can adjust the scatter scaling. Keep it at 1 or whatever, right? And so that's just the way to think of it. That I personally just keep it simple, like I said over here on multiple scatter. I just turn it on, have the weight at 1, have the amount at 1, change the color, and adjust the radius. And that's it. And that's how I'd work here. Basically, with single scattering, same way, same idea. I pick the color I want, I turn on the scatter scale and the absorption scale, and I just move it around. So if I need more or less scattering, I slide this around. If I need more or less absorption, I move that around. So if I were to do like 0.01, see how it starts bleeding in more? You can move that way. Yeah, you get the idea. So that's really the only differences between single scattering and multiple scattering. They work pretty similar if you keep things simple. The idea is they work basically the same way in terms of parameters. They just have different names, and the color you pick is the color you get. And all you got to do is adjust the scale, the thickness. That's the way you got to think of it. The radius is the thickness, how thick or dense your object is, and how far you want it to penetrate. And the only differences between multiple scattering and single scattering is single scattering goes in, goes out. It's faster to render, cleaner, but in my opinion, doesn't look as good as it. Well, it isn't as good, as realistic as multiple scatter, but multiple scatter is heavier to render and slower. So depending on the object you're making, you might do one or the other. I usually just use single scatter if I'm doing plastics, stuff like that, because it's not that complicated. The shape is, relatively simple. If you're making skins or fleshier stuff, weird substances, multi-scatter is just better. When there's lots of little textural details and bumps and displacements and stuff like that. Otherwise, stick to single scatter. It looks great. It's fast to render. It's overall easy to use. And so this is why I stick to these two methods. Why? Because you could do lots of options, and you can mix it with your diffuse maps, your reflections, etc., etc. So like right now, if I just change the diffuse here to this blue, or let's do it in purple. That's a little too bright, but it just works. The SSS is staying here as expected, only on the edges, and it's still the same color I picked before. So if I go to black or whatever, the only reason it's this warm color here is because the light on the side is warm. And so it just works out of the box really well. And you could do the same thing with multi-scatter. So if I just click this and come up to the diffuse, change the diffuse to this weird purple color, it's the same thing basically. Except, oops, the right now our colors, or actually no, this is down here. Right now we're using this blue color. If I go up to multi-scatter, change it to that blue color, we're getting something similar. Obviously I changed the radius and stuff like that earlier, so it's not exactly the same, but you get the idea. It just works. And so I personally like to, and also because multiple scattering is losing light inside of it more and blending more, we're going to get a little bit of a different look. But the idea is basically the same. So you just adjust the colors as needed. And so I like that it works easier. So we could drop this down like this. And yeah, you know, it's still there, it's subtle, and it's just easy to work with. Now, other people that are new to Redshift, they start using these nodes. The nodes I recommend you don't use because they're not really that intuitive and they're old. Even though they kind of updated them a little bit, they're old. So we've got the RS skin, and the RS skin is basically the same thing. If you see the shallow, mid, deep, those settings are basically the same as multi-scatters, layer 1, layer 2, layer 3. It's basically the same thing. But let's plug that in. The way it works is not so intuitive. And it also has single scattering as an option here. So let's just go over single scattering first. Let's pick one of those blue colors. And right now it's disabled. So if we increase the scatter amount, radius scale, overall scale, what's going on here? Well, there you have it. It's not working. I don't know why. Let me reload. Well, that's weird. And this is exactly why I don't like using this node. Because it's just not intuitive. It's so this is single scattering, and you just saw me moving that around. It did nothing. While when I was using this single scattering, it just worked. I just threw in the color I wanted and increased the scattering, and that was it. It just did what I wanted it to do. And so, yeah, I just don't like. I think this node is just, I don't know, it's a bad node. I just don't like it. It doesn't work well, in my opinion. It's not intuitive at all. And so, let's try a shallow scatter. And so this would be the first layer. So yeah, we've got a red. Let's turn it on. And so you see it's working kind of like the last time we were checking out multiple subsurface scattering. And you can increase the radius. So you see it's doing something. But it's just changing the color to the box. There's no like diffuse option really. It's less intuitive. So like to get a diffuse gray box to start with, I would need a gray color. And then I would need to increase the weight. You see? And then you adjust this layer. So it's more confusing. That now I've got a, okay, if I want, and then I adjust the radius. So like let's go back to our multi-scatter here, and let's just reset this back to how we had it before. So it was I think it was 0.254, 0.254, 0.254. Let's just do that. And the red we're using is 0.5 red. And so if I were to plug that in, we've got our radius and stuff. And I mean it just works. It's a lot more intuitive. I just pick the color I want. I have my diffuse color. I have my SSS color. The weight, I turn it on, and I choose how much I want it to go through the light. That's it. And the RS skin is just, you have to actually think of the deep scatter is actually the color of your diffuse, basically. And then you have your shallow scatter if you wanted to get that same effect, where it's a gray box. Let's just make this also gray. And so it just, in my opinion, it's just not as... You could get the same effect, basically, but it's not intuitive. It just seems more complicated. Like, why do I have to get the same gray box looking gray? Why do I need to make the deep and middle and all that stuff those colors? And so people will start using this node, and they'll be throwing in weird colors in here, and they'll be like, what the hell's going on? Because they don't get the colors that they wanted to get. And so, and right now, single scattering wasn't even working. I don't know what's going on there. And so, oh, there we go. So I guess we could do something like this. And adjust it as needed. But yeah, as you can see, it's pretty counterintuitive. It takes a lot more messing with each node, all these options, just to try to get the SSS to bleed through and be the color you want on the surface and the SSS. And that to me, this is just You know, it's too much work. Like it's too complex. That's why I tell people, don't use this node. Please don't use this node. Use the multiple subsurface scattering, and that way you don't have to figure out what all this stuff is, how you have to magically balance all these colors to get that result. When all you got to do with the RS material is just pick the color you want, diffuse color you want, and switch it to the first layer of SSS or single scatter SSS color you want, and boom, it just works. That's why I recommend use these methods. Don't use this. It's too confusing to try to get the right color out. It works. I'm not saying it doesn't work, but you know, there's two ways of approaching rendering. You could try to do it like super technical, or it could just be artist friendly. Most engines are going artist friendly now. You know, the RenderMan 21, 22 is going to be even more artist friendly. Arnold 5 is simplifying and stripping down everything, and so they're just trying to keep everything just, you slide this color, that's the color you get. And so that's why I tell people, this node, old, don't use it, just stop. Use these, use the RS material. It's artist friendly. That's what it's for. It's to do everything. So anyways, let's move on. But yeah, that's this node's just a disaster. And so the next option that is usable, I tell people you could use this. It's not, you know, it's not bad or anything, but in my opinion, you're better off still going with this route. But the RS SSS, so if you just type in SSS, you'll get the RS SSS. This node isn't half bad. So if we plug it into Surface, it works. It's a lot more intuitive than Skin. Skin's just horrendous. The RS SSS works a lot like the single and multi-scatter options, except instead of having all these other options inside of there, like the RS material has, it kind of removes all this stuff. And so all you're really left with is just SSS related stuff. And so what I like about it is it's a lot more simplified. So if you know your object doesn't need all these other parameters, like if you know you don't need like coding or whatever, then there's nothing wrong with using this node, because it's doing the same thing basically, but it's just simplified options. I personally don't use it. Like I said, I just stick to the Uber shader because I know how to use it. But there's nothing wrong with the RSSSS in that aspect. It's not as complicated. So RS SSS just works. The basically, if you go up to the general parameters, just put this at 0. We have 0 scale. We have 0 everything. It just goes black. We turn it back on. Whatever color you have here in your subsurface, it's basically the color, the color of the object. You also have a diffuse amount. You can increase this all the way to 1, and the object is now 100% diffuse. You could decrease this, and as you can see, it's getting a little more SSS, more transparent. Put this at 50% or whatever, and now the object's somewhat diffuse, somewhat SSS on the sides. So in that way, it's pretty simple to understand. The scatter radius, it does the same thing as the radius and stuff in the RS material. Same thing. So all you got to do is increase or decrease this. If you decrease this, if you put it to 0, there's no light going through the object. Put it 0.4 or whatever, there's a little bit of light going through. And obviously the higher you go, the more see-through the object gets. Pretty straightforward. um, the scatter color, and the subsurface color. The subsurface color, you could think of it as like the diffuse. It's not actually the diffuse, but I mean, that's the best way to describe it. So right now it's this gray, the same gray we had before up here, the 2.54. And so if we want red on the edges, like we did over there, we pick the scatter color. And that's it, really. And you just increase the radius. So this node is a lot like the single scatter and multiple scatter options. Right now, this is subsurface multiple scatter, and if I activate single scatter, it's like having both of these to put together. And actually, you could do that with the Uber shader too. You could have multiple scattering on, activated, and you right here, and you could also go down and activate subsurface single scattering. There's nothing, you could do the same thing. So what I'm trying to say is that everything this node does, this node does. The RS material does everything and more. That's why I tell people, you know what, I just use the RS material. Why? Because it just has more options, more control. But again, like I mentioned, this works well. I mean, there's nothing particularly wrong with this node. It's still pretty easy to understand. So you could increase the scatter amount, add a little bit of thickness, and as you can see, it's a similar result to what we had up here. Relatively easy to use. And there is a reflections options. So if you want specular highlights, right now we have specular highlights, and right now the only thing that's different about these two nodes too is that the specular system is glossiness, and the RS material uses roughness, which is basically the better option. It's the PBR option. And so if I were to drop this to 0.5, it's a little more diffuse now, so it's not a specular, just like we had 0.5 roughness on these, and we had GGX. And so, yeah, and we have Fresnel and IOR and stuff like that, and we could plug in bump maps. I mean, this node's not bad. I think it works pretty well. If you're going to just make a wax object or something like that, then yeah, you could use this node, no problem. And yeah, all you got to think of is subsurface color. Just think of that as the object densities color, which is kind of like the diffuse. And so if we crank this down, now the cube is like a bluish gray, like this color, but our scatter color is still this red. So it works as you expect it to work. And it's not too difficult to understand. And so you could add single scattering plus multiple subsurface scattering. You could just have multiple subsurface scattering. And then all you got to do is just increase the radius, decrease the radius. So 0 down to 0 basically means it's diffuse, more diffuse. Up here means that the light's bleeding through, and the color that's being scattered back out is this color. It's pretty direct. And so and the color that's being absorbed is everything else except for this red, so it's bouncing out. And then the scatter radius controls the density of the object. And that's it. So this node it works. There's nothing wrong with using it. I just, in my opinion, why not use the RS material that does the same thing and gives you more options, more control. So that's pretty much a summary of what's going on with all these options. The only node I really think is just really counterintuitive is RS skin. It's too weird. It's the old way of doing subsurface scattering with all the options and taking into account how the light's being attenuated and scattered back out and all that stuff. It works, but why do I don't want to have to tweak, what is this, 1 2 3 4 different color options and make sure that the opposites are the opposites to cancel out colors and stuff, when I could just use the RS material and get the job done with only a couple options, and the RS material does the same thing. I mean, the RS SSS is a lot easier to use, but it only has one layer, and you don't have all the it's not a roughness PBR approach, and also it doesn't give you all these other options to optimize the control. There's just way more options using the RS material. And so hopefully that explains to you guys what's going on regarding what these parameters do and how they influence the color and look of your object. And so again, in my opinion, use the RS material, stick to the multiple subsurface scattering if there's a lot of detail or it's a complex object like skins, stuff like that. Use single scattering if it's just a plastic or stuff that has SSS, but overall it's not a complicated multi-layered object. And I think that approach will render faster and look just as good if you're making plastics and stuff like that. And you could actually use this to make liquids also. And matter of fact, I should probably show you guys what I mean by that. Since some people have asked, how do you make like a murky liquid? So let's say this is like a water, I guess. Let's turn on refraction. So let's just say this is, well, maybe not this color, but let's make this white for now. And the diffuse color won't matter, so you can just turn this off because it's refractive. And so if this were a liquid, right, and you wanted it to have, actually let's make it less rough too. Let's 2.2. So you wanted it to be like a dirty pond or like those beaches where the water gets deeper and changes colors the deeper the object gets. This is how you make that effect. You basically make your object refractive like a liquid, and then you adjust the subsurface scattering, the single scattering. I guess you could do it with multiple scattering. I haven't tried it myself in Redshift, but I assume it would work. And so all you'd have to do from here is, if we change this is the surface color of our object, right? So if we were to, let's try, something. That's strange. Why is it only... Hold on a second. What's going on here? Okay, scatter scale. Yeah. There we go. Okay. So basically, you can think of it like this. Let's move this back to white. You can think of the transmittance, you could just leave that to the color of the object that you want. In our case, we want it to be like a liquid, a see-through liquid. And the scatter coefficient, you could think of that as the color that's bouncing around inside the object. And so this is probably not a good object to show, but we'll try it anyways. So if you do the, if you'll notice this, basically what's going on is the deeper the object is, or the further away basically from the camera, it'll start with this color. And what's happening is as the light travels in, the deeper and deeper and deeper and deeper into the object, more and more of this blue light gets absorbed. And so what you're left with is this red, which is the opposite. And so let me think of a way to best show this. Let's see. So let's say you want your water to be like a tropical ocean or something. What you don't want is the color in here. This is kind of counterintuitive, but that's because you want the color opposite to that. You see? So like if I wanted some, maybe this way, tropical blue inside, the deeper into the object we go, this is what the color you'd want. So just think of it that way. And your transmittance color is your top color. Well, that's too saturated. Let's and so what's happening is that the absorption, there's actually no scaling on here, huh? Hold on a second. Yeah, there we go. Okay, and so let's brighten this up. Let's do a little blue. And so for our example, we'll just make it blue. And we'll make the water dirty. So the opposite of green is this purple. And so what's going on is basically the color of your surface, which is the refraction color, and then the color that you want to happen the deeper the object gets is the color you want here in your scatter coefficient, and you want the opposite of the color you want. So if you want green, you want whatever's on the other side. And then your scatter scale will dictate how that is working. And then you have phase, which obviously, like I said earlier, lets you control the direction it's the light's going. But for our purposes, we'll leave it at 0. And so that's actually how the coffee preset, where's that at? Milky coffee. How that's working, except it's using extinction. And if you'll notice, it's not, the colors in here are not these blues. What they are is the opposites. And so that's the only time that I would say is kind of a little counterintuitive when you're working with if you're trying to make liquids or glasses or whatever that are changing color the deeper they get. That's the only time that things are a little weird, that you got to kind of take that into account. So if you go through here in this example, you'll notice that the color of our refraction is white. So if I change this to like red or whatever, our surface is that color. And so this controls your surface color, this parameter here. So if this was glass, for example, and this parameter down here, the scatter coefficient, this controls the color inside the object. And you usually want the opposite. So right now it's purple, opposite of purple is green, as you can see. Opposite of blue, we're going to get this yellowy orange inside. If I change it this way, we're going to get blue. See? So that's how that works. And then you just adjust the absorption, the scatter scale. So if I change this to 20 like the default, this is what we're getting. Change it to 10, you're getting a little more scattering going on in there. 15. Well, actually not. Well, yeah, it's not the scattering, it's the absorption basically. And so the color that's being absorbed. And that's if you're not using any diffuse. So right now we have diffuse turned off. That's why it's working this way. If we turn diffuse back on and we turn off refraction, it works just like you would normally expect it to. Basically, the opposite color in here. If we go here and switch this to just white, and now we change this color to blue, it's the color here. So the best way to think of it is transmittance color is the color that's coming in and going through the object, and this is the edge color, the outside color, before it gets absorbed. And then if you make this white and make this that blue, scatter coefficient, let's try 2. This is more of the color inside of the object, but because our object is diffuse currently, let's turn that off. Turn back on refraction. There's a difference in the color, in terms of the color. And actually, let's do something more like this. And so the best way to think of it is when you're working with a diffuse object, adjusting this or this affects it gives you the color you want, you expect. If your object is refractive and you don't have diffuse, you want the color that's going to be in here, you want to be the opposite of the color that you want deep inside the object. That's that you want absorbed, basically. And that's the way to think of it. So let's switch over to glass. So for example, we have a glass and we want the inside of the glass to be blue in our example. This is what we're going to get. The glass is blue in the inside. Why? Because the light that's shining in is being attenuated, and what you're left with, the deeper into the object, is the opposite color, which is blue. This will give us green. This will give us purple. And so on. And so changing it here basically just adjusts the the rate of absorption. So if we go all the way down to this, there's no color transmitting it deeper inside, basically. White, it's going all the way through. And adjusting the color up here is the glass itself. So if we had white glass, you know, it'll do that. So what you do if you want your glass to be like a blue or something, you pick your color up here. And so see, our glass is blue now. And if you want the inside of the glass to be a different color, you pick the opposite color up here. So the opposite of this, let's do purple. So we'll make it green. Actually, let's make it green. So we'll pick purple. And so now the opposite of this purple is this greenish color. And now if we increase our scatter scale, you'll start to see that green. And so that's the only thing to keep in mind regarding subsurface scattering. When you're the difference between if you're using refractive object or if it's diffuse. If it's diffuse, it just works with the color you want. You don't have to do anything. But if it's refractive, you need to use the opposite color. And that's the color you'll get inside, basically. So if I disable that, now we're back to just a blue refractive glass. And I've never actually tried it with multiple subsurface scattering, so let's see what happens. We crank this up to 1. And I think it might disable actually our refraction. I'm not sure. I don't think it works with it. Yeah, it looks like when it comes to refractive objects, it does not work with it. So, or at least not how I expected it to work. So just, well, let's see, maybe. Okay, it kind of works. It's just it seems like it's taking over. It takes over the object. So if you need water, glass, refractive stuff to change color, the deeper your object gets, just keep that in mind. Disable diffuse color, activate refraction, change the color to whatever color you want. You know, if you want a clear glass or whatever, but you want inside to be a different color, go up to subsurface and then increase your scattering scale to whatever number, to whatever, and then use the opposite color. And then just adjust the scattering scale to whatever you see fit. The reason why it's purple on the edges is because this glass is see-through, and so the color that's first being attenuated is actually purple. And if we actually just go to white, we just get this. And so we get no color attenuation inside. And then black obviously just basically turns it off. So to recap, pick your glass color or your liquid color or whatever, your tropical, beach, ocean. The color you want, and then pick the color, the opposite color of what you want the color to change to inside. And then that's how That's how that works. And that's only when you have to pick the opposite color. That's only in particular when you're trying to get the color inside of a refractive object to be something else. You don't have to worry about all that if you're going to just be using it for diffuse color that's coming in only a little bit. But I figured I would actually touch on that because that's, some people ask about how do I make something like that. And so if I do a 0.2, add a little roughness to it. And you can actually mix this with diffuse too if you want. So if your object's a little more diffuse like this, you get some pretty interesting effects basically. If we go all the way, then we've kind of made it less refractive. But so now we've got a little bit of diffuse, but the object is also refractive, and the refractive color is this blue. But then the inside, the deep color, is the opposite of this, which is this deeper red. I mean, not red, blue, darker blue. So if we want purple, all we got to do is go like this. See? If we want green, go like that. And so you can make some pretty exotic, weird materials like this that are, you know, pretty neat for, I don't know, some weird crystals or whatever, right? So yeah, that hopefully covered all the variables and options that you have for single subsurface scattering, how it changes when you're using refraction, how it works when you're using just a pure diffuse object, how you can mix the two if you want, and you could also mix in some multiple subsurface scattering if you want, now that the object is a little diffuse. I think multiple subsurface scattering really only works when the object's diffuse. So if we go all the way over here, we're getting what looks softer inside because it's bouncing around more often. But yeah, I think that explains the whole shebang of what's going on here. And so yeah, if you're going to be using refraction, just keep in mind the color of the inside depth, use the opposite. If you're just using diffuse, the color of the inside will mostly be affected by your diffuse color. So, alright guys, hopefully this kind of demystified the way that SSS works, both single and multiple, and hopefully you guys kind of see how you could combine it with diffuse, refraction, and really get some interesting results. And at the same time, why I personally don't use the RS skin. RS SSS is okay, but I still don't use it. And why I think everybody should probably learn the RS material, period. It's the one material to rule them all. You know, and so it's the uber material, the best material. So learn how to use it. And hopefully this helps you guys make more interesting plastics, glasses, water, liquids, things that have varying densities and colors that change the thicker the object is. And also you guys will learn how to make some skin and stuff based on the previous tutorial. And this gives you guys a lot of options and variations to tweak and make some really interesting materials, because Redshift renders so damn fast that honestly, why not make complicated SSS materials? In other engines it would take forever to clean up complicated SSS, but we've got Redshift, it's so fast, why not take advantage and put a little SSS in pretty much everything, because in the real world everything's got a little bit of SSS except for metals and stuff. So yeah, use it, take advantage of it, get wild with it, and you know, hope you guys learned some cool stuff. I look forward to seeing any neat experiments you guys make in the forums, or any of your Digital Emily experiments, or any cool plastics or weird stuff like this. Thanks again for all the support. Really appreciate it, guys. And I look forward to working on the next tutorial for you guys. Thanks.